EClogic EClogic tutorial. Tutorial video number 31. EClogic hysteresis setting. What is the purpose of hysteresis setting? Hysteresis is a generic configuration tool to trigger alarms based on different input. It enables you to trigger a status in Modbus based on thresholds limits of various measurements. Via the EClogic builder or linker, a status can be triggered, which triggers can be used to set general-purpose alarms. How to edit hysteresis setting in the EClogic. Go to the EClogic and click the linker. Then navigate to the hysteresis editing page by using the up and down arrow button. There you will reach the hysteresis editing page. Here in the hysteresis setting, all columns has to be edited correctly according to the Modbus slave documentation. The address column is the input for the hysteresis. The hysteresis is built up with a low threshold and a high threshold. If the value from the address is lower than the low threshold value, the low timer will start. After the lower timer has expired, the output box will change color to green, which indicates that the line is present. The status of each line can also be read out on Modbus. If the value from the address is higher than the high threshold value, the high timer will start. After the high timer expires, the output box will change color to red, which indicates that the line is not present anymore. It is possible to manually force the line to be set or reset by clicking on the buttons corresponding to the line which should be forced. Furthermore, it is possible to invert the output by clicking the button. Here the simulation back of module BOM temperature is 25 degrees Celsius, which will be used for the demonstration of this video guide. For example, in a back of module temperature hysteresis setting can be done for a monitoring or alarm or to a output switch, where the hysteresis setting will define how the output should behave according to the temperature fluctuation. Here a trip point can be set to 25 degrees Celsius and the hysteresis can be set to 1 degree Celsius or more in range. When the temperature reach the maximum trip point, the output signal status can be used to activate or deactivate, to turn on a cooling fan or to create an alarm. The back of module temperature is 25 degrees Celsius now. The green curve is an imaginary temperature variation curve during the day. Then the configuration going to be edited to activate the output if the back of module temperature varies than 1 degree Celsius. The sample configuration will be illustrating how the hysteresis logic works according to the setting, and you can notice outcome of the output behavior. Here the hysteresis has been edited for the BOM temperature. In this sample configuration, the back of module temperature address has been used to demonstrate the hysteresis functionality. 5 lines are configured with back of module temperature address with different low and high threshold. If a temperature variation occurred during this 5 seconds, then the output will be activated. Save the setting and let's wait 5 seconds. Here you can see the output activation status changed with green signal on line 4 and 5. What do we understand from this status change? For the line 1, 2 and 3. If the value from the address is lower than the low threshold value, the low timer will start. After the lower timer has expired, the output box will change color to green, which indicates that the line is present. Here in this case the actual value 25 degree is not lower than the set threshold values, and therefore after lower timer status did not changed because there is no trigger. But in line 4 and 5, the value 25 degrees Celsius from the address is lower than the lower threshold value 26 and 27 degrees Celsius, therefore high timer will start. After the high timer 5 seconds expires, the output box will change color, which indicates that the line is present. The invert button will be used to produce the outcome of the setting in invert manner. When you click the invert button, you can see the outcome of the output status reversing. Thank you for watching the video. This video presented by EClogic. For more information, please visit our website www.mcomb.com.